So yesterday we were discussing optics, right? Just a minute. So this was the last problem that we did, right? We'll try out some more problem based on refraction. Next, let's try out the ninth one. So there is a ray of light which is incident at the glass water interface at an angle I. It emerges finally parallel to the surface of water. Then the value of mu g would be how much? Just a minute. I think this is a simple problem. Ray of light. Sorry, just a minute. One minute. I'm getting a call. Ah, sorry, guys. Yeah, tell me how to solve this problem. So a ray of light is incident at a glass water interface at an angle I. It emerges out finally parallel to the surface of water. That the value of mu g is. So mu g means refractive index of gas. Mu w is the refractive index of water. So mu g into sin I is equal to mu w into sin r. Correct? Similarly, mu w into sin r is equal to 1 into sin 90 degrees. But these two are same. So I can relate these two. So mu g into sin I is equal to sin 90 degrees. So mu g will be equal to 1 divided by sin I. That's the answer. Right? So it's a simple problem. Shall we try the next one? See. An observer can see through a pinhole at the top end of a thin rod of height h. Okay. Placed as shown in the figure. The beaker of height 3h and its radius is h. Okay. When the beaker is filled with a liquid up to a height of 2h, he can see the lower end of the rod, then the refractive index of the liquid is how much? So when the liquid is filled to a height of 2h, what is happening? The ray starts bending in such a way that he is able to see the bottom also. Then what is the refractive index of whatever liquid is used? Mu L is equal to how much? How do we solve this, guys?
Sir, real depth by apparent depth. I'm assuming.
Real depth by apparent depth. Is there any other way? See, generally we use the real depth by apparent depth when you see from the top. Real depth by
Oh, yes,
apparent depth
yes.
comes
When viewed at view right angles, yes, yes.
yes, when you view it from top. But in the big level. So what can we do? Definitely we need to involve, see, refractive index problem apinale, you definitely need to apply Snell's law. And whenever you apply Snell's law, there might be a condition where you might have to apply trigonometry also. So I suggest you to think in terms of angles, trigonometry, and look for more number of right angle triangles. If you need to make some construction for that, do it. Okay, let's try this out in this front. See, generally, if this is a light source, okay, I drop a perpendicular here, and let's say this is the height 2h. Okay, so he is able to see the bottom like this. So if I drop a normal here, if this angle is I, right, then this angle is I, corresponding angles, correct? Similarly, if I take this angle as R, then what can I apply? So if this height is 2h, then this height is how much? It is h. Correct? Purida nanu kondrana.
Yes, sir, Puridu.
Then mu L into sin R is equal to 1 into sin I. Correct? So, if you take, I'm using other color C. If you take this angle, this as the right angle triangle, then how much is this angle?
90
How
minus
much
I.
is 90 minus I? This height is h, the radius is also h. Correct?
Yes, sir.
So, upper tan of 90 minus I should be equal to 1.
Oh,
So,
45,
cot,
sir.
yes, I should be 45 degrees. If I 45 na, R nambalukku theriyadhu. So for R, what we can do is again drop a perpendicular near para. So how to find R? Tan R is equal to h by 2h. Cancel it. 1 by 2. அப்ப sin R எவ்வளவா இருக்கும்? 1 divided by root 5. So take it and substitute it. Mu L into sin R is equal to 1 into sin I, correct? Mu L into sin R எவ்வளவு? 1 by root 5 is equal to sin I எவ்வளோடா? Sin I is 1 by root 2. So mu L is root of 5 by 2. Option irukka adha mari. That's the.
Yes, sir.
So, sir, in this chapter, we have to use mostly trigonometry.
In the case of refraction based problems, you have to use trigonometry. See, you can either use trigonometry or congruency of triangles, or sorry, similarity of triangles, but trigonometry is more easy. So, yeah. So, but
Yes,
one
sir.
point to be kept in your mind, trigonometry, now you have to search for more number of right angle triangles. If you don't have, you have to construct it. Because Snell's law involves trigonometric function. That is only a key. Okay.
Yes, sir.
Yeah. So shall I move on to the next one, guys?
Yes, sir.
You can try this 11th one, but tell me, I think it's a simple one. You can directly tell me the answer.
Mu4 is equal to mu1, sir.
That's it. That's it. Correct. You apply Snell's law 4 times, multiply everything, you will get the answer. Okay.
Or they appear to be parallel, sollama, sir.
They appear to be parallel. Diagram is not to the scale. Right? It is only a rough diagram.
Illa, sir, kuduthirken. Emergent rays parallel to AB.
Okay. Then you can take. It's something similar to glass slab
Yes, sir.
that you can say. Let's say you take a glass slab. What will happen to the emergent ray is parallel, right? So that emergent ray will be parallel to the incident ray, provided the outer medium on both the sides is the same. And the logic which is correct. Mu1 is equal to mu4. Okay. Move on to the next part. So we will try to use we'll try to discuss these problems. Okay, refraction through curved surfaces. So there is a formula, right? What is it? Mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. I told that was very important. Refraction at spherical surfaces. So when two transparent media are separated by a spherical surface, till now whatever we saw was separated by a plane surface. If they are separated by a spherical surface, then light incident on the surface from one side get refracted into medium on the other side. Spherical surfaces are of two types as shown in the figure. One is it can either be a convex surface or a concave surface. So convex or concave is dependent on where the object is placed. Since the object is placed here, it is undergoing refraction at a convex surface. Since the object is placed for the second one, since the object is placed on the left hand side, it is undergoing refraction with respect to a concave surface. Okay. So the formula is mu2 by v minus mu1 divided by u is equal to mu2 minus mu1 divided by r. So you have to remember it like this. Mu2 is the medium where the image is formed. Mu1 is the medium where the object is placed is equal to mu2 minus mu1 divided by r. And you need to remember that sign convention has to be used to solve these problems. Okay. So we will try one problem and see. One plano-convex lens and one plano-concave lens of the same radius of curvature are, but of different materials, are joined side by side. Okay. One plano-convex and plano-concave. These two are joined together to get the shape. If the refractive index of the material 1 is mu1 and that of 2 is mu2, then the focal length of the combination is how much? Okay. So I need to discuss a little bit of lens theory. Let's look into it. So what is lens? So lens is a uniform transparent medium bounded between two spherical or one spherical and one plane surface. So to put it in different way, if the refracting surface, if at least one of the refracting surfaces is curved in nature, then that particular refracting surface is what is called as lens. It can be curved on both the sides. It can be curved on one side. It can be plane on the other side, something like that. So if it is convex lens, obviously you know what is the answer. Convex lens is something like this, and concave lens is this. So convex lens is converging lens, concave lens is diverging lens. So what is the lens formula? 1 by f is equal to 1 by v minus 1 by u. And what is lens maker's formula? It is 1 by f is equal to mu 2, or refractive index of glass divided by refractive index of medium, minus 1 into 1 by r1 minus 1 by r2. Okay, where mu is the refractive index of glass. Generally, glass will be the material that is used for refractive medium, or you can take mu L also. R1 and R2 are the radii of curvature of the lens. Similarly, this can also be written as power. So how is power defined as? It is a reciprocal of the focal length of a lens. When it is measured in meter, it's called power of the lens. Power of the lens is 1 by f meter. Okay, so unit of power is diopter. The power of convex lens is positive, and for a concave lens, it is negative. Reason is very simple. When you take a convex lens, the first refracting surface radius of curvature is on the right hand side of it. If you take this as the origin, since it is on the right hand side, focal point will also be on the right hand side. That is why the power of a convex lens is taken as positive, means its focal length is also positive. Similarly, for a concave lens, it is negative. So what are the rules to be followed for the formation of image? If you take the rays parallel to the principal axis, they converge or appear to converge and meet at a particular point, which is the focus. Second, if the ray is passing through the optical center, it travels without any deviation. Third, if the object is placed at the focus, after refraction, it passes parallel to the principal axis. So these are all the 3 points, right? So image formation by convex lens. Again, you will have 6 images. Okay. So one is when the object is placed at infinity. When it is placed at infinity, the image is formed at f2. When it is placed beyond c, then the image is formed between f2 and 2f2. And it will be real, inverted, and diminished. At 2f1, what will happen? The image is also formed at 2f2. It is real, inverted, and of the same size of the object. Between f1 and 2f1, where will it be? It will be beyond 2f. It is real, inverted, and highly magnified. At f1, the image is formed at infinity. It is real, inverted, and highly magnified. At f1, between f1 and optical center, it is on the same side. It is a virtual image. It is erect, and it is magnified. Okay. So this is the advantage of a convex lens, due to which it is used like what? This is the reason why it has some special application. It is used as a microscope. All these points you know. So image formation by convex lens. So convex lens, what will happen when you place the object at infinity? The image is formed at focus. It is virtual, erect, and its point size. You place anywhere except the principal axis. No, sorry, principal focus. It is not axis. It is a principal focus. Then the image is formed between the lens and f2, and it is virtual, erect, and it is always diminished. Wherever you place, it is always diminished. Okay. Now, this is the important point. Focal length of lens combination. When the lenses are in contact, then 1 by capital F is equal to 1 by f1 plus 1 by f2. So power of combination is P is equal to P1 plus P2. When the lenses are separated by a distance D, then this is the formula. 1 by f is equal to 1 by f1 plus 1 by f2 minus D divided by f1 into f2. Or power can be taken like this. P1 plus P2 minus D into P1, P2. Okay. Similarly, linear magnification is given as V by U. Axial magnification is dV by du. In the case of mirror, it was minus dV by du. Here it is dV by du. Sharia. Next, when you cut lens, so If a symmetrical convex lens of focal length f is cut into two parts along the optical axis, then the focal length of each part is 2f. Okay. So if you cut it along this part, then each part will be 2f. Remember, it is optic axis. Optic axis means it is perpendicular to the principal axis. However, if the two parts are joined as shown in the figure, the focal length of the combination is again f. If the symmetrical convex lens of focal length f is cut into two parts along the principal axis, then the focal length of each part remains the same. If the two parts are joined with the curved ends, where is it? Focal length of each part remains unchanged as f. If these two parts are joined with curved ends on one side, focal length of the combination is f by 2. But on joining these two parts in the opposite sense, the net focal length becomes infinity. Okay. So with this knowledge, let's try to solve this problem. Now read the question. One plano-convex lens and one plano-concave lens of same radius of curvature are, but of different materials are joined side by side. If the refractive index of the material 1 is mu1 and the material 2 is mu2, then the focal length of the combination 1 by capital F is equal to 1 by f1 plus 1 by f2. Correct? So how to find 1 by f1? One by f1 is equal to mu1 minus 1 into 1 by, if I take this as the first surface and second surface, for first surface, what is the radius of curvature?
Infinity.
Sorry?
Infinity.
Very good. Minus 1 by R2 is how much?
R.
Minus R. And the left side, I told you have to see from here. Then what is 1 by F2? Mu2 minus 1 into 1 by so 1 by capital F is how much? So this is gone 0, this is gone 0. Mu1 minus 1 divided by R plus 1 minus mu2 divided by R. This is 1 by F. So F will be R divided by mu1 minus mu2. Is there an option like this? Guys, did you understand?
Yes, sir.
Done. Moving on to the next question. Are you guys doing an experiment called as liquid lens in your lab? Do you have an experiment named liquid lens?
No, sir.
No, sir.
You will find the focal length, refractive index of the material which is used. Some setup like this, you will have a convex lens. Below you will keep a plane mirror. Then you will take some liquid and put it here.
No, sir.
No. Okay. There's actually this is one of the experiments. Actually. Read this question and mark it as important. I think this is the last problem of your NCRT. Remember, I think there are 40 to 43 problems in ray optics. I think this is the last one. Mark it as important. This is slightly complicated. Read, I'll explain it, okay? Read all these points. So there is a thin convex lens L of refractive index 1.5. It is placed on a plane mirror capital M. When a pin is placed at A such that OA is equal to 18 centimeter, its real inverted image is formed at A itself. Okay, as shown in the figure. Okay, I'm stopping the question with this. I want you all to make an analysis and tell me how exactly the ray diagram is supposed to be for this. Okay. See,
So the object should be in 2F.
Object should have been in 2F had the image being formed on the other side. Correct? Had it been, had it only been lens, then what you are saying is absolutely right. Okay. But here, what is getting added? It is a combination of lens and mirror. Let's try to dissect this and understand. Okay. If I take this object as A, if there had been only plane mirror existing, then where will the image of this be formed?
At A.
So at A itself, right? That's where you're going to get. Now, when you place a convex lens, right? When you place a convex lens, what do you think should happen so that the image is formed back on the same side? See, what could have happened is the rays will go through the lens and they are definitely going to undergo refraction. The question is, how is the refraction supposed to undergo so that the rays are able to retrace their path? The refraction should take place. Listen to this carefully, okay? The refraction after the lens should take place in such a way that the refracted rays go and hit the mirror normal to it, so that when will the rays be parallel to each other? Only when the object is at infinity. Correct? So when the rays, so what is happening is these rays start behaving like an object to the lens. So once they get refracted, where will the parallel rays meet for a lens?
Focus.
So in this question, the point you need to be careful is many of them make the same mistake. They take 18 is equal to 2F. No, 18 is equal to F. Did you guys understand what I told? I'm repeating it again. Listen. So had there only been a plane mirror, yes, the image would have coincided with A itself. But since the lens is there, for the combination to produce the image at the same point where the object is placed, what is the necessary condition that needs to get satisfied? The rays coming from A should get refracted from the lens before hitting the mirror in such a way that the refracted rays should be perpendicular to the mirror in such a way that they're able to retrace their path and meet at point A. So when they fall normally on the surface, the distance at which the image is formed for set of parallel rays with respect to a lens is focal length. Are you guys able to understand? So indirectly, what did you get? You got the focal length of whom? Of the convex lens, which is 18 centimeter. So this is the focal length of convex lens. See, next time onwards, you need not do all these things. By default, you can directly start taking that as the focal length. Now, since you know the reason now. Now, let's read the next part of the question. Its real inverted image is formed at A itself. When a liquid of refractive index mu1 is placed between the lens and the mirror, the pin is moved to point A dash. It is slightly moved up such that OA dash is 27 centimeter. To get its inverted real image at A dash itself. The value of mu L is how much? Means initially it was air medium that was present. Now a liquid is dropped. We don't know what that liquid is. Our work is to find the liquid's refractive index. When you do this experiment in the lab, right, there you will generally use water. Okay. So let's see what exactly is happening. Now tell me, after the liquid is dropped, where is the final image formed? At 27 centimeters with respect to the mirror. Correct? So if in the previous case, without the liquid medium, it was the focal length of the convex lens. Now with the liquid medium, that should be the focal length of whom? See, for you guys to visualize, when you pour the liquid, no, it is at the bottom. The liquid is actually taking what shape?
Okay.
This is where the liquid is. So liquid is in black color and the lens is in red color. So the liquid is taking what shape? It's taking the shape of plano concave. Correct? It is taking the shape of a plano concave. Now, this is what is called as liquid lens because it is made up of liquid and it is taking the shape of a lens. Another liquid lens. Now, this 27 centimeter shouldn't be the combined focal length of the existing convex lens and the liquid lens. Guys, does this make sense?
Yes, sir.
Right? So, what formula are we going to apply? 1
1 by
by
f is equal to 1 by f1 plus 1 by f2.
1 by f2. So, if you take this point as the reference, anything above the principal axis, if you take it as positive, let's try to find out. 1 by then f1 should be negative. See, focal length is taken for this side. So if you take, in this case, if you take the downward direction as positive, you can take anything actually, okay. 1 by f equivalent. F equivalent, it is 1 by 27 is equal to 1 by, what is the value of f1? It is 18 plus 1 divided by, what is the value of f2? That is what we need to find. So 1 by f2, 1 by 27 minus 1 by 18. So 18 minus 27 divided by 27 into 18. How much is it? Minus 9 divided by 27 into 18. It goes 2 times. So F2 is equal to minus 54 centimeter. So the focal length of the liquid lens is minus 52 centimeter. Okay. So our interest is to find out what is the refractive index of the liquid lens. So for that to happen, we need to think of the formula that is able to relate the focal length to the refractive index. So what formula relates? 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. That is the lens maker's formula. So since we don't know what is the radius of curvature of the liquid lens, we need to apply this formula twice. 1 by f1 is equal to mu minus 1 into 1 by r minus 1 by minus r. That is mu minus 1 into 2 divided by r. Let this be 1 by 18. That is 1. Similarly, 1 by f2 is equal to mu minus 1 into 1 by r1. R1 euro. R1 is minus r because upward is taken as negative. 1 by minus r minus of 1 by infinity because it's a plano convex. So it is mu minus 1 into minus 1 by r is 1 by f2 order minus 54. Let this be 2. So second divided by first will give us mu minus 1 into minus 1 by r divided by mu minus 1 into 2 by r into is equal to 1 by 18 divided by minus 1 by 54. This goes 3 times. R goes off, minus gets cancelled. So mu minus 1 divided by 2 into mu minus 1 is equal to 3. So mu minus 1 is equal to 6 into mu minus 1. 5 is equal to minus 6 comes this side. Am I missing something? Because I'm getting mu as 1. That's not possible. Minus 1 by 54 divided by 1 by 18. This should be 3. Minus and minus gets cancelled. It is 1 divided by 3. Two by 3. So how much is that? 3 mu minus 3 is equal to 2 mu minus 1. So mu is equal to 4.
2 வருது சார்.
2 வராதேடா. Mu is equal to 2.
ஆமா
Option
சார்.
இருக்கா?
இல்ல சார், ஈக்குவேஷன் படி அப்படிதான்.
Can someone tell me what mistake I made? I made a mistake. Check. In the equation 1 and 2, there is a small mistake. I'll give you a hint also. 1 is right. 2 lo oru chinna thappu irukku. What is it? I took it as mu minus 1. It is not mu minus 1. It is refractive index of the liquid minus 1. Because F2 belongs to the liquid lens. It doesn't belong to the already existing thin lens. So the correction I should have done is mu L. Then mu L minus 1 into minus 1 by R divided by mu minus 1 into 2 divided by R is minus 1 by 54 divided by 1 by 18. This goes 3 times. So R and R are gone. Minus sign gets cancelled. So 3 times mu L minus 3 is equal to 2 mu minus 1. But mu is given as 1.5. So 3 minus 1, that is 2. Yeah, 5 by 3 would illi engiyo. I think it should be 4 by 3. Two mu minus 2. It is 1. 1 plus 3, 4. 4 divided by 3 is the answer. See, so next time onwards, if this problem comes, what you can do is, you can directly take, these are the steps. You can take F1 as the focal length of the convex lens. Okay. From there, you apply 1 by F equivalent. Find the focal length of the liquid lens. Then apply the lens maker formula twice, divide the equations, you will get the answer. Got it?
Yes, sir.
Okay. I hope you guys have copied it. We'll try the next one. So there is a convex lens of focal length 20 centimeter, which produces images of the same magnification 2 when the object is kept at two distances x1 and x2 from the lens. The ratio of x1 by x2 is how much? So how to solve? So magnification is given as 2. Right? Magnification is given as 2. Is it plus 2 or minus 2? Because they didn't say whether it forms a real image or a virtual image. So what we can take is, we can take plus 2 or minus 2. What is the formula for magnification of lens? M is equal to V divided by U. If M is 2, it is V divided by 2x1. If M is minus 2, it is V divided by 2x2. Okay. Oh, sorry. V divided by x1. So use this scenario. 1 by V minus 1 by U is 1 by F. 1 by V is 2x1 minus 1 by U is minus x1. Okay. U and rather we will take it as x1 because it's an unknown. Is equal to 1 by F. So minus 1 by 2. Minus 1 by 2x1 is equal to 1 by F is given a focal length is 20 centimeter. It's a convex lens. So 20 up x1 evada 10 10 centimeter with a minus sign. What about x2? 1 by minus 2x2 minus 1 by x2 is equal to 1 by 20. Minus 3 divided by 2x2 is 1 by 20. Cancel it. So x2 is equal to minus 30. x1 by x2 evada 1:3. Irka option 3:1. Oh, they have told x1 is greater than x2. Sorry, I didn't see. So then x1 should be 30, x2 should be 10. So x1 by x2 should be 3:1. Guys, did you understand what I did?
Yes, sir.
Okay. Shall we move on to the next one? Try this. Formation of real image using a biconvex lens is as shown in the figure. If the whole setup is immersed in water without disturbing the object in the screen position, what will one observe on the screen? So what will happen? So you need to calculate the focal length of this lens in air medium and the focal length of the same lens in water medium. Water's refractive index is 4/3. Okay. So 1 by F in water is equal to mu minus 1 into 1 by into 2 by R. So mu, the refractive index of the lens is how much generally if it is made up of glass. Okay, refractive index of glass is 3/2. So 3/2 minus 1 into 2 divided by R. Cancel it. is actually mu g divided by mu w. Mu g is 3 by 2 divided by 4 by 3 minus 1 into 2 divided by r. So how much will you get? 9 divided by 8 minus 1 into 2 divided by r. That is 1 by 8 into 2 by r. Cancel it 4 times. So you'll get it as 1 by 4r. So that is 1 by fw. But what is the focal length in air medium? That is mu minus 1. So 1 by 2 into 2 by r. So cancel it. Focal length in air is r. So focal length in water is 4 times the focal length in air. So what is happening to the focal length? It is increasing. Means where will this object's position fall with respect to the lens in the water?
Beyond 2f.
Focal length is increasing now, then this point f will shift this
Oh,
side.
between
Between
f and
f and up in image work.
real image.
Sorry?
Oh, so magnified image.
Virtual.
You'll get a virtual and a magnified image. Purida? There's a good question actually. See, these simple values you can remember, right? Try this, no? So there is a plano-convex lens of focal length f2, refractive index mu2, and radius of curvature r fits exactly into a plano-concave lens of focal length f1, refractive index mu1, and radius of curvature r. Then their plane surfaces are parallel to each other. Then the focal length of the combination will be. Read the question, try this out, and tell me how to solve. There is a plano-convex lens. Okay. Of focal length f2, refractive index mu2, radius of curvature r. Fits exactly into a plano concave lens, means they both are like this. Okay. I think it is something similar to first problem. It is mu2 f2 r, mu1 f1 r. Their plane surfaces are parallel to each other. Plane surfaces are parallel to each other. Then the focal length of the combination will be 1 by f equivalent is equal to 1 by f1 plus 1 by f2. So 1 by f1 evlo? Mu minus 1, that is mu2 minus 1 into 2 divided by r. 2 divided by r, 1 by r. One by r negative, 1 minus 1 by r. 1 by f2 is mu1 minus 1 into minus 1 by
Sir,
r.
நம்ம கான்கேவ்க்கு வந்து 1 by infinity minus 1 by r னு போடணும்ல sir, like, and then for
1 by
convex you have
infinity.
to put 1 by minus 1 by.
Oh, then it
Oh
is
my.
plus 1 by r.
Oh,
okay.
okay.
Mu2 minus 1
Sir,
into 1
அது
by
வந்து then for convex வந்து it will be 1 by r minus 1 by infinity, right?
minus 1 by r minus of 1 by infinity. அப்ப இங்க minus 1 by r வரும்.
Yes.
இது first actually numbers வந்து they have wantedly given you by swapping per. இதை நான் 1 எடுத்திருக்கேன், இதை நான் 2 எடுத்திருக்கேன். 1க்கு வந்து mu2 இருக்கு, f2 இருக்கு. So be careful with that. அப்போ 1 by f2 வந்து இது, 1 by f1 is this thing. They wanted to interchange the number. So 1 by f equivalent will be equal to.
Convex negative radius. I mean negative radius of curvature.
For second, first one it is plane.
Oh, okay.
This first, this
Yes.
second. From left to right. Mu2
Sir,
minus
1 by infinity minus 1 by r and like convex lens na it's radius of curvature positive.
டேய் அப்படி இல்ல, ரேடியஸ் ஆஃப் கர்வேச்சர் அது பை கான்வெக்ஸ் நீ சொல்றது. அது ஏன் பாசிட்டிவ்னா ஃபர்ஸ்ட் சர்ஃபேஸ் தான் எப்பவுமே ரெஃபரன்ஸ் விச் எவர் சைடு யூ ஆர் கீப்பிங் தி ஆப்ஜெக்ட். ஸோ ஃபர்ஸ்ட் சர்ஃபேஸ் விச் திஸ் ரேடியஸ் ஆஃப் கர்வேச்சர் இஸ் பாசிட்டிவ், this radius of curvature is negative. இப்போ the way I've drawn the plano convex, this side is infinity, this side will be minus r. That is why minus r. Sorry, inga minus r.
Okay.
So mu2 minus mu1 divided by r. R by mu1. It's actually the first problem. First problem enna ketanga? What was it?
The same, sir.
Same, right?
Yes.
Same question. Okay. Okay. Yeah. Let's move on to the next one. You guys read the sixth question. What is the position and nature of image formed by lens combination shown in the figure by referring to our focal length?
Sir,
You
இது
guys-
கிட்டத்தட்ட இந்த empathy problem mechanism.
NCERT that. It's an example problem, NCERT. It's almost same except numbers. Try one, do it fast and tell me. No? It's very simple. So here the object is there. First lens, second lens. So image formed by the first lens will act as the object for the second lens. Do it and tell me. Make it fast. Use proper sign conventions. Anybody with the answer? So where is the image formed due to the convex lens? So B is how much? It is 4 centimeter. So I'm getting it correct, Ada? So V is 4 centimeter. So the distance between them itself is 2 centimeter. So 4 centimeter, the image is formed somewhere over here. This distance is 4. So this point P will act as the object. 1 by V2 minus, what is 1 by U2? 1 by U2 is 2 is equal to 1 by F2 is minus 5. Did I miss something? There is no option. 1 by V minus 1 by 20 is equal to 1 by F.
So
Yes. I made a mistake here. Minus 1 by 20. It's 3 by 20. So it is 20 divided by 3. 20 divided by 3 na 6 point something. So 20 divided by 3 minus 2 euro.
14 by 3.
Did anyone get the answer?
Sir, I think I got the same. Not sure.
தப்புடா நான் பண்ணது. And I made a mistake in the calculation. 20 by 3 வந்ததா? V is 20 by 3. See,
Yes, sir,
the distance between 20 by 3 na, it should be on the right hand side. Correct? And 6 point something on the distance. 20 by 3 na, in the distance the object distance. 20 by 3 la 2 போச்சுனா எவ்வளோ? It is 14 by 3. அதுதான் object distance. So 1 by V2 minus 1 by 14 by 3 is positive. Don't make a mistake by taking it as negative. So 1 by V2 minus 3 by 14 is equal to minus 1 by 5. 1 by V2 is equal to minus 1 by 5 plus 3 by 14. So minus 14 plus 15 divided by 14, it is 1 by 70. 1 by 17 or 1 by V2. Up V2 on the 70. Is there an option of 70? Positive value 70 centimeter beyond point B at right. Point B correct. And I'm getting, and this is a real image. Yes, that's the answer. Guys, I hope you guys are understood.
Sir, அந்த -2 ஏன் பண்றோம் சார் 20 by 3 ல இருந்து?
ஏன்னா see, இப்போ இது வந்து 20 by 3 ன்னு வருதா? If you directly start using it as 20 by 3, you are trying to, இப்போ என்ன பண்ணிருப்ப நீ பண்ண தப்பு என்னன்னா -20 by 3 நீங்க போட்டுருப்ப கரெக்ட்டா? Did you do that mistake?
ஆமா சார் 20 by 3 தான் போட்டேன்.
மைனஸ் போட்டுருப்ப. With
ஆமா
minus
எஸ்
sign.
சார். எஸ் சார் வித் மைனஸ்.
அது ஏன் பண்ணனா, see the thing is the distance of separation between them is very important. நான் என்ன சொல்ல வரேன், had this lens not been existing, then the image due to this convex lens would have formed at a distance 20 by 3. 20 by 3 into 6 point something, which is greater than the distance of separation between these lenses.
Oh, so it will be formed beyond the concave lens.
Beyond, ஆமா அங்க வரதுனால, since with respect to the optical center, the image, since the image is formed on the right with respect to the concave lens, from the optical center, if you measure it to the point where the final image is formed due to convex lens, that will become the object distance for whom.
So okay, that is 20 by 3 minus 2.
20 by 3 minus 2. Other you have to be very careful. Don't use minus 14 by 3. Maybe I use one. I think you will get the answer as 20 by 3. They have given it to confuse you. But I'm assuming that you will get that answer.
Plus use panda because it's in the right hand side of.
It is on the right hand side. That's
okay.
That's simple.
Okay. Thanks.
So inga pathana inga kuda 17 varudha. So that is why it is formed on the right with respect to the optical center of lens B. Point clear on the right real. Had they given 70 centimeter from B at left up in kuduthiranga, you should not get confused. So be careful with that. Okay. So that's the outline. So let's try this problem. So all these are actually NCERT based only. Ray optics, your NCERT is actually good. The problems are very good. You can try them also. An object is at a distance of 20 meters from a convex lens of focal length 0.3. So convex lens focal length is positive. The lens forms an image of the object. If the object moves away from the lens at a speed of 5 meters per second, the speed and the direction of the image will be how much? So what is given? U is 20 meter. Correct? F is 0.3 meter. du by dt is 5 meter per second. Okay. Either a sign convention, I'll take this as negative. Now let's see. Du by dt is speed, right? It's not velocity. Speed. So, yeah. So 1 by f is equal to 1 by v minus 1 by u. Now,
So இதுக்கு டெரிவேட்டிவ் எடுக்கணும்.
sorry, da?
இல்ல சார் இதை டிஃபரன்ஷியேட் பண்ணனும்.
Yeah, with respect to time. So 0 is equal to, don't write as minus 1 by f square because for a lens focal length is fixed. Minus 1 by v square into dv by dt minus of minus 1 by u square into du divided by dt. Upper dv divided by dt is equal to 1 by v square divided by u square into du divided by dt. So v value, I don't know. Nothing is known, no? Except focal length, nothing is known. So we'll do one thing. If I can I write 1 by v is equal to 1 by u plus 1 by f. I can write it as f plus u divided by uf. So v will be equal to uf divided by u plus f. So uf divided by u plus f the whole square divided by u square. U square into du divided by dt. Appa enna varum answer? F square divided by u plus f the whole square into du by dt. Purida? So f square is how much? 0.3 square. That is 0.3 square na 9 by 100. 0.09 divided by u is minus 20 plus f is 0.3 into du by dt is 5. So the square. So 9 by 100 divided by minus 19.7 the whole square into 5. So 10 square later, I can make it as 197. So 9 divided by 197 the whole square into 5. You guys have to calculate and tell what is the answer. Okay. So remember one thing with respect to a lens, you move away. Okay. If the object is away, the image will be closer to the lens. If the object is closer to the lens, the image is away from the lens. Simple as well. If the object is moving in the leftward direction, the image will also move in the leftward direction. That is why if you observe the ray diagrams, when you place it at infinity, it will be at focus. So it keeps going like that. When you keep coming close to the lens, the image will also keep moving away. Correct? So answer enakku theriyala, but it is towards the lens. So option should either be A or B. That part I'm leaving it to you. Okay. We'll do one more problem. So I think they are mostly concentrated. They mostly concentrate only on lens. But how many problems are there in 2019 itself? You guys can check last year's paper also.
சார் லாஸ்ட் இயர்ஸ் பேப்பர்லேருந்து நிறைய வேவ் ஆப்டிக்ஸ்லேருந்து சம் வந்து சார் அண்ட் ஃப்ரிஞ்ச் வித் அதுலேருந்து
அதுவும் இருக்கும்டா. Wave optics also they will definitely test. Ray optics there is no problem at all or what?
சார் ஆக்சுவலி வேவ் ஆப்டிக்ஸ்ல அவங்க ஃபார்முலா பேஸ்னு கேட்கறத விட்டு லைக் ஆக்சுவலி அந்த டெரிவேஷன் இருக்குல்ல சார் லைக் அதுதான் சார் மெயினா யூஸ் பண்றோம் அந்த சம்ஸ்ல கூட. அந்த
ஆமா,
sin theta
derivation.
theta அப்ராக்ஸிமேட் பண்ணி லைக் அந்த மாதிரி
Exactly.
क्वेश्चंஸ்னால only there.
That's what they will ask. அதுதான் முக்கியமே. So that's why derivation is important, because a part of the derivation will also act like a formula. சரியா? பார்க்கலாம் அந்த சாப்டர் வரும்போது பார்க்கலாம்.
Sir, ray
So there is-
optics they directly asked one lens makers formula question, sir.
Lens maker last year.
Some 8th Jan shift to நினைக்கிறேன் sir.
Okay. I think it is easy only.
ஆமாமா, that was easy sir. Directா 1/r1 minus 1/r2 க்கு வந்து 0.08 னு வரும். You directly cancel will come sir.
Okay. So I think you should be able to do better now. Let's see. There is a plano convex lens of refractive index mu1 and focal length f1, which is kept in contact with another plano concave lens of refractive index mu2 and focal length f2. The radius of curvature of the spherical faces are each, and f1 is equal to f2. Then mu1 and mu2 are related by what? There is a plano convex lens of refractive index mu1, focal length f1 is kept in contact with another plano concave lens. Okay, so here I cannot draw an exact diagram. The reason being, it can be like this also. Whereas in the previous problem, if you see, they told that these two are getting fit inside each other respectively. So they are in contact out of them. That's there. If the radius of curvature of the spherical faces is r, and f1 is equal to 2 times f2, f1 is equal to 2 times f2. But here one technical point to be remembered is, we don't know the sign convention, because if I draw it like this, and if I draw it like this, in both the scenarios, it is not necessary that they both have the same sign. They can change. So adhanala what we need to do is, we will take f1 is equal to plus or minus 2f. That is one important point. So when I say plus or minus, you can take the modulus on both the sides. So mod of f1 is equal to mod of 2f2. Okay, let me take it like this. And mu1 and mu2 are related by what? So 1 by f1 is equal to mu1 minus 1 into 1 by r1 minus 1 by r2. 1 by f2 is how much? Mu2 minus 1. The refractive index of mu1 and mu2, right? Mu2 minus 1 into 1 by r1 dash minus 1 by r2 dash, because they both have the same radius. Then r1, r2 only. Okay. Then can I write 1 by f1 inside a modulus is equal to mod of 1 by f2? So mod of mu1 minus 1 into 1 by r1 minus 1 by r2 is equal to mod of mu2 minus 1 into 1 by r1 minus 1 by r2. R1 evlo? For a plano convex lens, this is infinity, so this part will disappear. Here we will take this as 0. So mu1 minus 1 into minus 1 by r is equal to plus or minus mu2 minus 1 into minus 1 by r. So let's take the positive values of it. Since I'm taking the modulus of it, 1 by r is gone. So mu1 minus 1.
Sir, actually அது 1/2 வெளில இருக்கணும் சார். ஏன்னா f1 equal to 2f2 னு கொடுத்து.
Or 2 is there, correct?
Sir, அப்பனா it must be 1/2 னா சார். ஏன்னா நீங்க ரெசிப்ரோக்கல் ஈக்குவேட் பண்ணிருக்கீங்க.
Then 1/2 னு வரும்ல?
ஆமா சார்.
Okay. Then it should be 1/2. இப்போ கரெக்ட்டா? Then 2 times mu1 minus 2 is equal to mu2 minus 1. So mu2 minus 2 mu1 minus mu2 is equal to 1. Irukada option. 2 mu1 minus mu2 is 1. 2 mu1 minus mu2 is 1. Option C. Okay.
சார் ஆக்சுவலி எனக்கு இந்த லென்ஸ் மேக்கர் ஃபார்முலால எப்போ வந்து அது அந்த இன்ஃபினிட்டியும் ஆரும் மாத்திரம் எப்படி இது பண்ணணும்னு மாத்திரம் ஒரே
I'll take.
தெரியும்.
Sure. இப்போ இப்படி எடுக்கிறேன்னு வச்சுக்கோ, plano convex, whatever lens for that matter. Sir, now first convex lens is explain. Okay, if you take as convex lens, name the left hand surface as 1, right hand surface as 2, because R1 belongs to the left hand surface, R2 belongs to the right hand surface. Formula 1 by F is equal to refractive index of glass divided by refractive index of the medium. Refractive index of the medium divided by the refractive index of the outside medium. Generally, we take it as -1 into 1 by R1 minus 1 by R2 is the formula. Okay. So if suppose you take the refractive index here as mu and here as 1, most of the cases it will be mu minus 1 into 1 by, let's say this is a biconvex lens with equal focal length, okay, equal radii. Upon what will be the value of R1? So this will be a part of the sphere whose radius is on the right hand side. So R1, is it positive or negative?
Positive.
So 1 by R, minus is already in the formula. 1 divided by R2 comes from the second sphere. R2 the radius in the bakka irukum.
Oh, okay.
Okay. So that will become mu minus 1 into 2 by R. Adanal da nariya vaati paathana, I'll directly write this. Now let's take a plano convex lens. Plano convex appdi solranga, plane convex. That's meaning. Okay. Ipa mu minus 1 or 1 by F is equal to mu minus 1, same story. 1 by first surface, second surface. Ipa sollu niye sollu. 1 by
1 by R minus.
First surface is what?
Oh, first surface 1 by minus.
1 by infinity.
Oh, 1 by infinity.
Minus is in the formula.
Oh.
1 divided by minus R. This is 0.
Okay.
Mu minus 1 divided by R. Purida. That's the logic. So we'll do one last problem. Let's try this instead. Let's try instead. So there is a convex lens. The convex lens is put 10 centimeter from a light source and makes a sharp image on the screen kept at 10 centimeter from the lens. So there is a convex lens where the object is placed at a distance of 10 centimeter and the image is also formed at 10 centimeter. Now tell me what the 10 centimeter is. Harini, you're there?
Yes, sir.
Now what will the 10 centimeter be? You told it previously, for some other problem.
Oh, focal length.
This will be 2 times F. I'm repeating it again. With respect to a convex lens, the image and the object are at the same distance when you place it at the center of curvature, which is 2F. I didn't apply this logic to the liquid lens because it was not the convex lens alone that was existing. What was existing along with it? It was the mirror. So if it is convex lens and mirror based problem, then the distance at which the object and the image coincide are what is the focal point of the lens. Whereas if it is only lens, then it is 2F. Purida, are you guys able to understand the difference? No confusion, right? Yes. So just a minute, the charge is over. Just give me a minute. So 2F is 10. Upper F there is 5 centimeters. So focal length of a convex lens is positive. So let's write it. So F is equal to plus 5 centimeter. Let me take this as 1. Okay, next. Now a glass block of refractive index 1.5 of thickness 1.5 centimeter is placed in contact with the light source. To get the sharp image again, the screen is shifted by a distance t, then the distance d is what? It's a good problem. This is first scenario. From this, f is 5 centimeter. That was easy. Now, I'm going to ask you a question. So there is glass block of refractive index 1.5 and 1.5 centimeter thickness. Refractive index is also 1.5. It is kept in contact with the light source. Okay, accepted. Now the screen is shifted. This is where we need to be careful. Is the screen shifted towards the lens or away from the lens? Or else you will not understand whether to take minus sign or this. Is the screen moved towards the lens or away from the lens? I told you one important point. As you keep moving close to the lens, where will the image move? It will move away, correct?
Away.
So, where should the screen be placed? Should it be moved to the right or to the left? So for that, we need to know how is this light source getting shifted? Means, see, previously what happened, this was the only source. Try to understand, guys. Now, since you have introduced a glass slab, they have used the word glass block, but it's actually a glass slab, correct? It is a glass slab of thickness T with refractive index 1.5. So what is the shift that is going to take place for the object with respect to a glass slab? There is a formula, x is equal to T into 1 minus 1 by mu. Yesterday we saw this. So what is the thickness of it? It is 1.5 centimeter into 1 minus 1 by mu is 3 by 2. So it is 1.5 into 1 minus 2 by 3, no 1 by 3. So 3 by 2 into 1 by 3, cancel. So the shift that is taking place is half a centimeter. Now, where is the actual object? Where is the actual object? Is it still existing at 10 centimeter? The answer is no, it is existing at 9.5 centimeter. Yeah.
Can I shift half centimeter?
It has got
towards the
shifted
right?
by, it has got shifted to the right by 1.5 centimeter. Does it make sense? Then the screen which was here, since the object has moved close, 9.5, it is less than 10. Since the object has moved close to the lens, the screen should be moved away by a distance t. If you don't know this point, what would have happened? Had you moved the screen towards the lens, then you would have taken the final image distance as 10 minus d. It is actually 10 plus d. That is the important point I want you to understand. Guys, does that make sense? Are you guys able to understand and visualize it? If yes, I will proceed. So no response, there is some doubt. What is it?
Sir, I have.
So others also, I hope you have understood. Okay. So 1 by v dash minus 1 by u dash is equal to 1 by f dash. Simple. 1 by v dash. Now the problem is simple. 10 plus d minus 1 by u dash. 1 by minus 9.5. Otherwise minus 95 divided by 100. Otherwise minus 19 by 20 is equal to 1 by 5. Calculate it and tell me what is the value of it. One unknown, one equation. Do it fast and tell me.
Sir, it's 95 by 10, right?
95 is 19 only in the India. It's 5 less.
Sir, the first equation.
இல்ல சார் 9.5
One.
நாக்க
It's
Oh, 95 by 10. Sorry. So it is 2 divided by 19. 1 by 10 plus d is 1 by 5 minus 1 by 19. So 19 minus 5, 14 divided by 5 into 19. 5 into 19 is 95. So 10 plus d is 95 divided by 14. Negative. Negative answer. Did I miss something? 1 by 5 minus 1 by 19 minus 5 divided by 5 into 19. 5 into 19 is 95. So 10 plus d is 95 by 14. So d is 95 by 14 minus 10. What are the 95 minus 140 divided by 14? I'm getting a negative answer. Can you guys calculate and tell me what it is? Two by 19. 19 minus 10 divided by 5 into 19. So how much is this? 9 divided by 95. So d is equal to 9 by 95 minus 10. Sorry, 95 by 9 minus 10. You go 95 now, 5 divided by 9. So 5 divided by 9 is 0.5 times is 45. Again, you will get 5 as a reminder, 5555 something. So this is the answer. Option 0.55 centimeter away. See, they gave towards also.
Sir, I have a doubt.
Tell me.
Sir, in the question, it's given that the glass block is placed in contact. Now, should it be on the left or right?
It is in contact, it is on the left of the right of the source. Because if you place here, then what is going to happen? You mean to say it will get shifted this side and you want to take this distance and do.
Like, how do we calculate that?
See, logic simple. I understood what you're asking. Why can't the glass block be on the other side? Okay, I'll answer your question. Then the image of the source is formed at a distance of 9.5 centimeter from the lens. Right? This makes sense. Right?
Okay, sir, I understood. Like, if it's placed on the other side, it won't even go into the
it won't go. Means what will happen? The glass slab will again keep refracting. It keeps getting shifted on the other side.
Yes, sir. Yes, sir.
Yeah, that is why it is not placed this. So that's it from my side, guys. So tomorrow we will see prism and the optical instruments. With that, we are done with this chapter. Then we'll see wave optics. Sure, yeah. So just a minute.
Yes, sir.